to 6 to repair. So after that, the battery was commissioned in September 2023. Initially, after revamping and with a pushing level of 83-84, we found that there is a considerable SPM other. So to reduce the chimney emission, because it was not at all possible to put some shutdown and do the repair as per requirement because of techno-commercial effect. So we found out some innovative idea that let's try one thing. So we brainstorm and partner with our vendor partner itself. So we implemented a system water. So it is the water chimney system. It is been initially it was supposed to be installed in the chimney at the middle of the chimney, which is having height of 120 meters, but due to some structural instability, fearing structural instability, because we have to do some additional holes and like that. So we just stop it and we do it in the bottom. So the detail will be explained this of it.
Good afternoon, everyone. So the topic of our presentation is reduction of SPM emissions from coke oven battery. As I already discussed the background, so I would like to proceed further. So currently coke oven battery is only running from coke oven gas, as there is no mixed gas available and there is no scrubbing facility available, hence clean gas is being used for battery heating. So this is the process flow of coke oven battery. With the images, we can see the degradation in refractive after prolonged shutdown for 3 years due to moisture ingress and thermal shock. This schematic explains the SPM carryover mechanism inside the coke oven battery. Due to partial repair of the battery post decommissioning, cross leakages exist and dust from the carbonizing chamber enter the heating flues through these leakages. Dust particles gets carried away with waste flue gas through tunnel up to the chimney. This ultimately results in high elevated SPM emissions and stack alerts. So after understanding the mechanism, we carried out a detailed Gisborne analysis to identify all possible contributors to high SPM. So different factors were analyzed and each identified cause were validated through operational checks and field observations. Parameters such as drought control, charging practice, analyzer response, upkeep activities, and dusting practice were found to be operating within control limits. So we started exploring possible design interventions for external dust suppression at the chimney. Different SPM reduction options were evaluated considering the aging condition of the battery and the need to maintain continuous operations. Options involving major refractory repair, structure modification, or full-scale gas cleaning systems were not feasible under current operating conditions. Therefore, we focused on practical emission control measures which could reduce dust carryover without disturbing normal battery operation. Based on this evaluation, flue gas dust suppression system was identified as the most feasible options. However, implementing the spray system also involved multiple site-related challenges and design constraints. After evaluation of multiple vendors, Lechler was selected for the spray system design. As per the standard design concept, spray nozzles were recommended at a 45 meter level. However, installation at this elevation required new drilling and structural modification on the chimney shelf. Since the existing opening at this level was already occupied with the SPM analyzer, any additional modification posed a risk to chimney structural integrity and therefore was not feasible. Maintaining chimney draughts during spray operation was also a key challenge. So, the spray system design was further optimized according to actual site feasibility. Instead of installing the system at higher elevation, the spray arrangement was redesigned for installation at the chimney bottom using existing nozzles and access ports. This eliminated the need for any fresh drilling or structural modification. A customized bottom-mounted spray system arrangement was developed to ensure effective dust separation while maintaining continuous battery operation. So this is the site visit. Photos of the inside card. So a total of 3 water spray nozzles were installed inside the chimney in an umbrella type structure as seen in the image to ensure effective coverage across the flue gas path. These sprays generate fine water droplets which interact with the dust laden flue gas, increasing particle weight and promoting settling. Additionally, 2 flushing nozzles were installed to flush the settled dust into dust collecting pit and prevent re-entrainment inside the chimney. During commissioning, spray pressure and water flow were optimized to ensure stable and consistent system performance. So here are some photographs captured during the actual site implementation and commissioning activities. So after commissioning of the chimney spray system, continuous monitoring of SPM trend and chimney drought was carried out. Post implementation, about 40 to 50% reduction in SPM alerts have been visible, stable chimney drought pressure and better stack emission compliance. Although zero emission could not be achieved due to inherent aging related limitations of the battery, but significant improvement in environmental performance was achieved without affecting continuous operation. Going forward, regular dusting, ceramic welding, flue grouting, clouding nozzle maintenance and continuous SPM monitoring will be continued for further improvement. Thank you.
What was the chimney draft before and after this project?
Before it was at -30 and after it is we increased by 131.
It increased actually.
Yes, sir. Increased 1.
No, I find you have implemented it there in the battery, right? So when you were drilling the hole for this spray nozzle system, there is refractory lining inside the chimney.
So there is no new hole installed. Actually, we have used the existing holes.
You have existing holes
in the battery. That are being used. No new hole has been done.
That is a good advantage you have taken from.
Yeah.
But is there no loss of the draft?
No loss of draft because it is basically creating a fog. There are 2 lines. One is the air line and the water line. So it is creating inside the chimney. So whenever
it is a dry fog. Is it a dry fog kind of system?
Fog. So it is a fog. So whenever the dust, the wet gas passes through the fog, so the dust settles down. So it will not allow the dust to go through. So that dust will settle down. But there is no impact on the temperature because the draft is mainly depend on the waste gas temperature, and we are not seeing any predominant change in the waste gas temperature. And continuously also, like whatever I mentioned, so there is a chance of jamming of the dampers because when the dust is flowing, so we are continuously operating the chimney dampers once per week, so that there will be no dust. Due to dust, there will be no damper choking or damper. So that is continuously doing because funnel damper is continuously operating. There is no need. But for chimney damper, because it's manual, so we are every week we are doing a overhauling of type of thing of chimney damper. So, yeah.
On the height side, I was thinking that while a lot of us are in the process of making new batteries.
Yeah.
So why not we have pre-drilled holes in the chimneys even during the initial erection stage, so that later on this kind of situation each and every coke maker is going to face in the future.
Yeah,
or maybe facing right now.
Yeah.
So if we have pre-drilled holes in the chimney, that kind of arrangement already there, so we utilize it later on. So that is the thing. That's a very good thing which you have brought out. So we have always doing this, but we have never been able to do this because we didn't have any hole or whatever conditions were not there. So
nowadays, if you are going the precondition from the Central Pollution Control Body, you have to have 4 holes in the 30 meters height, means approximately 1/5 of the 1/4 of the chimney height to install soft paralyzer. So that is now a CPCB condition. So you have to do the drilling of the holes. So that 3 to 4 holes at 30 meters height.
Yes.
But after that, you need to install more holes so that in case, because whenever there is a gas changeover, so SPM control the norms of CPCB, so you need to have 0 alert. And whenever there is a gas changeover, suppose you have been mixed underfiring and you are going to switch over to CO underfiring. So for till you adjust the draft, till you adjust the gas pressure, all those things. So for one day you have to have some alert. So to eradicate those issues, so this is a system which can easily implementable and can reduce our
And
alerts.
how much SPM could be reduced with this?
See, our alerts is coming around for day 25 to 30. Now we have maximum 5 to 10 alerts per day, maximum. So
But in the last set point,
alerts is 50 mg.
50 mg per hour per day.
Yeah, yes, 15 minutes average.
Another question, is your chimney structural or civil?
Civil.
And the sludge that is deposited at the chimney damper area, how are you making it out? Because I understand it is.
Yeah, I know. Yeah, already explained that there are two flushing nozzles.
Yes.
Three is for creating that fog, and there is some
I
flushing
understand.
nozzle.
Flushing is nozzle, you are cleaning the chimney damper area, but it is a sludge and it is
It is
probably
coming-
around 8 to 9 meters below ground level, isn't it?
Yeah, so it is coming to that. There is a beside the tunnel damper, there is a holder to carry out condensate. So from that condensate is coming to the seal pot. From seal pot we are taking out the every time the seal pot is taking the waste gas water, na. The
Okay.
waste gas tunnel having a hole which is carrying the condensate to the pot. From that pot you are carrying
Through chimney dewatering route, they are
yeah,
taking water.
chimney dewatering system.
Very good. Very good.
थैंक यू। अब मैं टीम JSPL रायगढ़ टीम को आमंत्रित करना चाहूंगा।
Good afternoon, everyone. And I'm Kunal Dwane, and I'm with my colleague Mr. Sandeep Rathore. And I would like to thank Bokaro Steel Plant and RDCS for organizing this operating committee. And we are from Jindal Steel Limited, Raigad, and we are operating a point in Middleton horizontal time heat recovery coke oven. And the topic for our presentation is operational resilience. Mitigating the monsoon-induced productivity losses via integrated cold moisture control system. As you all know that monsoon is the most painful time period for coke ovens and for the whole steel industry. We lost the productivity and we have many challenges with the flowability of the coal, and this also affects the coke oven battery refractory, as it results in the thermal shock, and it also requires additional time to evaporate the moisture, extra moisture, then the carbonation starts. So it results in the productivity loss around 10%, and we see as coal moisture going as high as 14.5% in our plant, and our desired range is 9 to 10%. So to mitigate this problem, we have installed a cold dryer. It is a 250 dph cold dryer, and it is a rotary drum type dryer which runs at the 3 rpm rotation, and it is designed to reduce the moisture level by absolute 5%, and we use blast furnace gas as a fuel, and we don't rely on the HSD or LDO as a primary fuel, because as you all know that there is a crisis going on in the Middle East, and there are a lot of fuel challenges. So we are totally working this cold dryer within the blast furnace gas only. These are some operational and economic benefits that we are getting from using this cold dryer. As you see that we don't need to give extra 3 to 4 cooking hours to get the coke ready for pushing. So we are saving that 3 to 4 hours of extra time. And secondly, we are maintaining the cold moisture level in the Goldilocks region, where we require 8 to 90% of moisture in our coal, and we don't rely on the external fuel buying HSD, LDO, etc. And it also maintains the process of our coke. So there is no variation in the coke quality during the monsoon season. And this is the photograph of our 250 TPH cold dryer. These are some of the comparative chart which based on our last year's performance. So you can see that during monsoon our moisture goes as high as 14.5%, mainly in the peak monsoon season. And using this dryer, we reduce the moisture by 5% and maintaining the cold moisture in the desired range. And it is also helping us in not giving maintaining the cooking time throughout the monsoon season. We don't need to give extra cooking time for the coal to get carbonized. That is helping us in pushing and maintaining the production level throughout the monsoon season. So earlier we had to reduce the pushing from 65 to 63 or 62 to maintain the quality and to get the coal ready. So we are maintaining 3 pushes per day using this dryer, and the standard deviation also in the coke quality, mainly the CSR CRI, which are the critical parameters for blast furnace productivity. It goes up to 1.2 standard deviation during the monsoon season. So we are maintaining the coke quality also using this dryer, and we are gaining around 105 tons of coke on a daily basis during the monsoon season. So, as you all know that coke is a very important player in the financial of our steel making. So, maintaining a coke production level during the monsoon season, it plays a big role. And these are some of the technical safety interlocks which are being installed with this cold dryer. So first of all, we are using the blast furnace gas as a fuel, and which is mixed with the combustion air, and it creates a hot air, which is called a hot air gas generator, and it is set at a temperature of 600 degrees Celsius. So if the temperature exceeds beyond 600 degrees Celsius, the BF gas line automatically there is a shut off hole, so it turns off. And we have a bag filter installed with it, so the outlet temperature, which is the inlet for the blast with based on the parameter.
We are reading from that to rotate that. So you have to also some conveying systems so that party also